So we've gone out, done our study, we've got a spreadsheet, say, of scores. But those scores themselves don't really mean much to us. Human beings are not good at looking at a list of numbers and picking out trends in those numbers. We just really can't do it. We're terrible at it. And so what we're going to do is look at methods of actually evaluating the data and trying to find trends, trying to summarize it in some way and say something useful and exciting about it. The first thing we want to do is just to get a bit of an idea of what is in our data. So what are the characteristics of our sample? And that's when we start to use descriptive stats. So descriptive stats give us this way to kind of reduce that big list of numbers, that meaningless spreadsheet, into something that's manageable, and we can start talking about summaries of information. So we kind of do this all the time in everyday life when you see a mean or a median reported. So if we're talking about climate change, we're looking at mean temperature rises. We're not giving someone a list of all the possible temperature rises. If you're trying to buy a house, you're looking at median house prices in an area. You don't go and access a list of 100,000 houses that might be in that area and then try and work out whether or not you can afford one. So we want to get into some meaningful and manageable summary. And that's what descriptive stats actually is. So they allow us to organize, summarize, and simplify the raw data in some way. And I really like this one here, making order out of chaos. So that's what you do. So you can, as a human, digest it in some way. If that's descriptive stats, what is inferential stats? The key thing here is that descriptive stats are just looking at the data you have in front of you. So if we're talking about, let's say we have measured our whole population. We didn't need to do a sample. We could somehow access our entire population of interest. Then descriptive stats will tell us about the population parameters. So there'll be things like the mean in the population, the standard deviation, the variance. So if we have access to a whole population, we can use descriptive stats on the population. What we normally do, though, is we apply it to the sample. But it's the same thing. It's the mean, the standard deviation, the variance, some characteristics of the sample data. To remind you about the difference between the population and the sample, when we're talking about things in the population, they're called parameters. So just remember that. P goes with P, so population goes with parameter. So we would have something like the Greek letter mu. Looks like kind of a weird U shape. Mu is the mean in the population. The little O next to it is sigma. Sigma means the standard deviation in the population. And sigma squared is the variance. And we'll talk about why that is in this lecture. And so whenever we use Greek letters, we're talking about the population, so we're talking about parameters. So P and P. If we're talking about the sample, then we're going to talk about statistics. They're the same thing, just in the sample. So sample, statistics, S and S go together. And so we use regular letters or Roman script. And so we would use M for the mean of the population, of the sample, S for the standard deviation of the sample, and S squared for the variance of the sample. So they're the same things as the Greek versions. They just apply to the sample. That's more of a technical point, but just when you know if you're looking at an equation and it asks you, is this the standard deviation for the population or for the sample, one of the hints you'll get is it using Greek or is it using Roman script? One of the easiest things, though, is that most of the time we don't have access to our population. We only have access to the sample, so you should hopefully have been getting this mantra drilled into you, mainly by me, over and over again, that we don't have access to the population. So we use the sample to say something about the population. So we use a sample statistic to estimate a population statistic. So we have the sample mean, which we use, so M, we use to estimate mu, because we don't have access to that. And that's what the inferential part of inferential stats actually means. So we go from our sample statistic and we infer a population parameter.